guys, we'll focus in a little bit there. All right, so I'm gonna clean my camera, guys. Hold on. All right, hopefully that helped out just a little bit. Yeah, that helped out a little bit. All right, good. Okay, sorry. All right, guys, this is where things start to get a little gooey. So, we're kind of working with a bunch of different things. Yesterday we did sine and cosine derivatives. Now we're going to work with more trig derivatives or trig functions. So you're going to see it in different ways. The way it is on the top of your worksheet says d dx. Just remember that this here just means the derivative of the tangent. And this variable here will always match that variable here. So like on your worksheet, it says d dx tangent of x. That's because this is x. So it's with respect to x. So just understand that this can change, but this just means the derivative. So again, like we talked about before, this is the same as y prime. This is the same as f prime of x. So we're taking the derivative of it. So the derivative of the tangent is this here. So you guys ready for this one? All right. So let's tackle our first one. How to get my brain wrapped around it here. All right, so let's just tackle a tangent. So if we're given y equals the tangent of 5x, I'm not going to go ahead and worry about doing the u prime thing for u and u prime for these. We're going to need it for some of these other ones. So if we look at this, we know that our y prime, our derivative of tangent of 5x with respect to x, which is what this means right here, is going to be the secant squared of 5x, so these are always going to match because that's the inside, times the derivative of the middle piece here, which is times 5. So we always take the derivative of that, the derivative of what's inside. So we get 5 secant squared of 5x. Okay? So I'm not going to worry about, as you guys get faster and faster with this stuff, you're going to know that this 5 comes from there. And that way it saves you a lot of time. And you learn by doing, not by memorizing. There are some things you have to memorize, but to do repeatedly helps you memorize it. So you will get to a point where you're going to go, oh, tangent of 5, that 5's got to move out front, and I'm going to leave one inside. So you'll get a little bit faster at that. My room is starting to smell like smoke. There's something burning around here. I'm starting to smell like, yeah. All right, so here we go. Let's try another one here. Let's do secant of 5x. So same thing, equals the secant of 5x. So again, remember that this 5 is going to end up out front. So we're down here at secant of 5x because this 5 is u prime. So my u prime is going to be, if this is u, my u prime is going to be 5. So I just put my u prime here. Let's just assume that that's u. Okay? And it's going to be times the derivative of the secant of u with respect to u. Well, I'm going to keep the secant of u, secant of 5x, times the tangent of 5x. And that is my y prime. Okay? All right, so you guys are all, oh, yay, this is all fun. It's all right. It's all fun and games when somebody gets their eye poked out. Here we go. Cotangent. Now all of a sudden, it's like the year 2020. They just go like 0 to 60 and like, well, there it is. So now we've got this whole other world here. So we've got really the cotangent of 3x to the 4th power. Now all of a sudden we got a chain rule with a derivative problem, and then it's like, why do you do this to us? And calculus hates me. So that's why you know the nickname of the class now. Here it goes. So if we're going to do y prime, that's y. So if we're going to start y prime, let's just tackle this. Derivative of the inside, the derivative of the whole thing, 4 times the cotangent of 3x to the third power. That's the start of the chain rule. Don't have to use any trig functions just yet. Now I've got to take the derivative. I got to take the derivative of this. And we're going to do that by utilizing, we're at cotangent, this right here. We know that this is u. So we're going to do cotangent. So we're going to get a 3 out here. Okay? So off to the side, I have cotangent of 3x. Kind of like what we did earlier. This is going to become the derivative in the front of the inside times our negative cosecant squared of 3x. This is my u prime. This is my derivative. Okay? You guys okay with that? This gets plugged in right here. So I'm going to put it in right here. Let's clean all this up. 4 times 3 is 12 times a negative, negative 12, times our cotangent, of 3x to the third. You can move it back in there if you'd like. I just leave it like this. Times, the negative already was moved out front, cosecant squared 3x. So, that is our equation. And this is our y prime. Okay, if you have to, rewind it. Chain rule was applied to this. 4 times the coefficient in front gives me 4, subtract 1. That's the start of the chain rule. Then I had to take the derivative of the inside, which sent me over to my trig derivatives. We know from doing trig derivatives enough, this 3 is u prime. That u prime is going to pop out here. And then I just got to take the derivative of this piece here. Well, the derivative of cotangent is negative cosecant squared of 3x. I insert that in, clean it up algebraically, and there we go. Okay? Like I said, they're starting to get a little gooey, guys. We're going to do these today in class, too. All right, so let's do the last gooey one. So we've got y equals cosecant of 3, what is it here, to the 2x. Okay, so we get that, we have it like this. You know me, I like to rewrite these. Cosecant 2x, to the third power. Makes it a little easier. So now, here we go, y prime. Inside, with the large exponent, we are going to do our chain rule. 3 goes to the front. I keep what's inside. I keep always writing the wrong one. Cosecant 2x, subtract 1. Now, here we go again. Now I have to take the derivative of the inside. The derivative of the inside leads us to our chain rule here. Not our chain rule, our trig function and our trig derivative. So I'm over here. I have cosecant 2x. We know that the u prime is going to be 2. And then I take the derivative of this, which comes from that formula. I'm going to get a negative out in front. That's the negative here. I'm going to get the cosecant of 2x. C's stay together, so I'm going to get cotangent of 2x times u prime. I already did u prime. It's right there. That would be u, so therefore that would be 2. The negative comes from the actual derivative formula, And so this gets inserted down here, negative 2 cosecant 2x cotangent 2x. All right, now we got to clean this all up. Let's clean it up. Y prime, negative 2 times 3, watch out, don't subtract them there. Negative 6, finish with this, cosecant 2x squared times cosecant, 2x times cotangent 2x. All right. Why did it not? Oh, that's right. There we go. That is it. There's our derivative right here. Technically, it'd be cosecant squared, cosecant 2x cubed, but that's where we can end up right there. There is our derivative. We are good to go, and we will practice a lot of these. Good luck, guys.